This lesson is on solving radical equations. So a radical equation is simply an equation that has a cubed root, a square root, a fourth root, some sort of root in its problem. So for example, if we have the cubed root of 2x plus 7 equal to 3, this is considered a radical equation. It has a radical in it. Whenever we're solving a radical equation, the very first thing you need to do is isolate the radical. Isolate the radical simply means get it by itself on one side. So in this case, we have the cubed root on the left side by itself. It has nothing added or subtracted to it on the outside of the square root, the cubed root, sorry, and it has nothing multiplied. It's isolated. So once it's isolated, to undo a root, we use a power. So what that means is I'm going to take this cubed root of 2x plus 7 and I'm going to cube it. And cubing it will undo this cube root. However, this is an equation, so what we do to one side we must do to the other. So the cubed root of the cubed root cubed undoes this radical, and we're left with 2x plus 7. On the right side we have 3 cubed, which is 27. So now notice, once we've eliminated the radical, we've ended up with a polynomial equation. So that means it could be linear, quadratic, cubic, quartic, it could be anything. For the most part, it's going to either be linear or quadratic. Okay, those are the two big ones we work with. So this is linear because it's got a power of 1 on the x. So the next thing we're going to do is subtract 7. We're going to solve this now linear equation. So 2x equals 20, and then we're going to divide by 2. So x equals 10. Now, we normally might check just to make sure it works. However, if you'll notice over here, it says that you must check your solution for extraneous solutions. This is important. This means this is not an option. Okay, so a lot of times with solving, checking is a good idea, but if you don't check it, it's not going to cause you too much heartache. In this case, if you don't check, you could possibly get a wrong answer. Okay, you can get answers that look like they work that really don't. So that's the next thing we're going to do. We're going to come over here and we're going to check the solution by plugging 10 back into the original problem. So the cubed root of 2 times 10 plus 7, is that going to equal 3? Well, 2 times 10 is 20. 20 plus 7 is 27. So the cubed root of 27 is 3, and 3 equals 3. So this works. Now, I did this by hand, but you can just as easily check it using a calculator. Just plug it in. But you've got to make sure it works. So since this answer is correct, we're going to box it, and that's all we have. We have one solution for this particular problem. Okay, let's look at another one. So we're going to have 8 times the square root of 10 to the x minus 7 equals 9. So the first thing I want to draw your attention to is the fact that this minus 7 is not underneath this radical. Okay, be very careful with how you write your problems, because by accidentally making your radical too long or too short, depending on the problem, it could really mess you up. So we have to isolate this square root of 10x, which means we're going to have to get rid of the times by 8, this right here, and we're going to have to get rid of this subtract 7. Now, just like a linear equation, we would add or subtract first, we're going to do the same thing here. So we're going to add 7 to both sides first. So that's going to give us 8 square root of 10x equals 16. Now we're going to take and divide both sides by 8. Now notice, this is only one term, 8 square root of 10x. So this becomes a 1, and I have the square root of 10x equals 2. To undo a square root, yep, you've guessed it, we need to square both sides. So by doing so, we eliminate this radical, and we're left with just 10x. On the right side, we have 4. And then our last step is to solve for x by dividing by 10. So we're going to reduce that. 4 divided by 10 is 2/5, or you could put a decimal, which would be 0.4. I would probably just stick with a fraction. Now, I probably shouldn't have boxed that just yet, because we need to make sure this actually works. So I'll erase that, because if it doesn't work, then we're going to say no solution here. So we're going to plug this back in. We're going to check. by taking this back to the original problem. So 8 times the square root of 10 times 2/5 minus 7 is at 9. So again, I'm doing this by hand. So 10 times 2/5 is 4. The square root of 4 is 2. 8 times 2 is 16, and 16 minus 7 is 9. So this does actually work. So x equals 2/5 is a correct solution. Okay, and again, you can use a calculator, just plug it into the calculator and see if it works, especially if you're short on time. But if you want to do it by hand, this is how you do it by hand, and in your notes, you might want to write it down so that you won't forget to check. All right, number 2. X plus 1 equals the square root of 7x plus 15. Now, when we look at this problem, we should notice that it does have two variables. It has an x on the left and it has an x on the right. And we know that we're trying to solve for them, so eventually we need to get them on the same side. However, one of our variables is underneath the radical. So this is a radical equation. We have to isolate the radical first. So notice that the radical is on the right side all by itself. It's already isolated. So our first step would be to square both sides to undo that square root. So if I square the right side, I also have to square the left side. And notice I'm putting x plus 1 in parentheses. That's because I'm going to square that sum. Okay, whatever that equals when you have an x. So you have to put it in parentheses when you square it. Now on the right side, that square undoes the square root. So all I'm left with is 7x plus 15. However, on the left side, I have x plus 1 squared. And if you remember, x plus 1 squared means write it twice. X plus 1 times x plus 1. Which means we have to distribute this product. So x times x is x squared. X times 1 is 1x. 1 times x is 1x. 1 times 1 is 1. Now when we did all that multiplying, we ended up with a quadratic because of this x squared term. So that means we're going to have to either factor, complete the square, or use the quadratic formula. Most likely it will factor. But if it doesn't factor, my backup would most likely be to use the quadratic formula, and both of those require this problem to equal 0. So the first thing we're going to do is we're going to simplify the left side. I'm going to combine those like terms. And then I'm going to get this equal to 0. So I'm going to subtract the 7x, and I'm going to subtract the 15. So we have x squared minus 5x minus 14 equals 0. Now, if you will recall, factors of 14 are 1 and 14 and 2 and 7. And I know that 2 and 7 can be combined to make negative 5. So we're going to have x and x, plus and minus. They're different signs because of the 14. We need a negative 7 and a positive 2. And we're going to check it. X squared, positive 2, negative 7 is negative 5. 2 times negative 7 is negative 14. And now we can use our zero product property. So if x plus 2 equals 0 and x minus 7 equals 0, that means x is negative 2, or x is 7, or x is both, or x is neither. Because we're not done, we have to check our solutions. So we're going to have to check both of these. Okay, so we're going to check our negative 2 first. So negative 2 plus 1. And then we have 7 times negative 2 plus 15. So negative 2 plus 1 is negative 1. On the right side, we have negative 14 plus 15. And negative 14 plus 15 is the square root of 1. And if you'll recall, the square root of 1 is just 1. And negative 1 does not equal 1. So what that means is negative 2 is not a solution. We cannot use this one. Okay? So now we have to check 7. So we're going to plug that one in. 7 plus 1. We'd have 7 times 7 plus 15. So 7 plus 1 is 8. 7 times 7 is 49. And 49 plus 15 is 64. And the square root of 64 is 8. So that one works, which means our only solution is x equals 7. X equals -2 is an extraneous solution. Does not work. Okay, so let's look at a word problem. So, in a hurricane, the mean sustained wind velocity v, okay, so the fact they tell us what v represents, v is the mean sustained wind velocity in meters per second, is given by a function. So as soon as I see a function, I'm writing that function down. So v of p equals 6.3 times the square root of 1013 minus p. Okay, where p is the air pressure, P is the air pressure in millibars at the center of the hurricane. They want us to estimate, okay, that's important, estimate, which means our answer is not going to be exact, we're going to have to round, the air pressure at the center of the hurricane when the mean sustained wind velocity is 54.5 meters per second. So this mean sustained wind velocity, that's going to be our V. Okay, so V equals 54.5. So we have to know if we're plugging in for V or P, which means where this V of P is, I'm going to plug 54.5. So 54.5 equals 6.3 times the square root of 1013 minus P, and we're going to solve. So our first step would be, again, to isolate the radical. So we're going to divide by 6.3. Okay, so make sure you're typing this into your calculator. So when you divide 54.5 by 6.3, you get approximately 8.651 something, something, something. So we're going to round this to about 8.651. And I am putting the approximate symbols because that tells anybody looking at my work that I rounded. Okay, and it's okay to round here because they told us to estimate. Now, once we have the radical isolated, we're going to take and we're going to undo the root with a power. So because this is a square root, we need a square. And we have to do the same thing to the other side. Okay, so on the left side here, hopefully you've kept that number in your calculator. So even though I've rounded here, I'm going to leave my calculator number where it is to keep it as exact as possible. When you square that, you should get about 74.836. And again, double check me in case I've missed some numerals or something. And that's going to equal 1013 minus p. So now we have a linear equation. So our next step would be to subtract 1013 from both sides. Again, that number's already in your calculator, so just do minus 1013. And that should give us negative 938.164 is approximately negative p. Don't forget to bring the negative with the p. That belongs to him. So we're not quite done, and hopefully you would know that's not done because we couldn't have a negative air pressure. That doesn't really make sense. So now we're going to divide by a -1, and that's going to give us 938.164 is approximately p. So we now need to go back and answer the question, attach our units, don't leave naked numbers. So our answer here would be that the air pressure at the center of the hurricane is approximately, and since we might only round to maybe one decimal, maybe we'll round to a whole number. It doesn't really tell us where to round, just as to estimate. So since it's millibars, it's air pressure, I'm going to say about 938. Okay, so about 938 millibars. And again, it doesn't say where to round, so if you round it to tenths or hundredths, the more decimals, the more precise. But I went ahead and rounded it to a whole number because I figured this is probably something we'd see in a real life problem. So about 938 millibars is the pressure at the center of the hurricane. Okay, so there's a example that you might see in a word problem. All right, now let's look at when we have more than one radical in our equation. So what I mean by this is if I had something like the square root of 2x plus 5 minus the square root of x plus 7 equals 0. So now we don't just have one radical, we have two radicals. However, we still need to isolate a radical, okay? So we don't want two radicals on the same side. The problem can be done that way, but it's really, really complicated. And you don't want to make this more complicated than necessary. So the fact that this equals 0 makes us really, really happy. Because what that means is we can take this one of these radicals to the other side by adding or subtracting. Okay, the best one to move would be to move the one that has the subtraction. So by adding, this is going to allow us not to have to work with any negatives. Okay, so save yourself a little bit of grief. Get each radical on the separate sides. Keep them apart, far, far away. Okay, so we have the square root of 2x plus 5 equal now to the square root of x plus 7. So now we can undo a radical with its power. So since these are both square roots, that's nice because we can square both sides. And when we do so, we eliminate the radical on the left, but we also eliminate the radical on the right. So now we're just left with 2x plus 5 equals x plus 7. And now that's really nice because that's a linear equation. So to solve this, we're going to get the x's together. So I'm going to take this 1x over to the 2x. That gives me 1x plus 5 equals 7. And then I'm going to subtract 5. So x equals 2. But again, you must check for extraneous solutions. So when I check this, is 2 times 2 plus 5 minus 2 plus 7 equal to 0? Well, we have 4 plus 5, which is the square root of 9, minus the square root of 9. Square root of 9 is 3, and 3 minus 3 is 0. So our solution works. So this is not an extraneous solution. Okay? All right. Let's look at number 4. The square root of x plus 2 plus 1 equals the square root of 3 minus x. Alright, now looking at this one doesn't make me as happy as the last one because we do have two radicals, but we also have this constant involved right here. So if we move it to the other side, we're going to end up with minus 1. That doesn't make the problem any easier. So what that means is we just have to kind of stick with it. So we are going to we have a radical on each side, so that's good. So now we're going to undo those radicals with a power. So the power we need is a square. Again, we have to put the entire right side and the entire left side in parentheses when we square it. Now the good news is the right side is now simplified. The bad news is the left side is kind of a hot mess. So if you'll recall, this means write this twice. We're going to have to distribute this expression. Okay, now the right side, again, we like that side. The left side, not so much. Now, those of you who know your properties, know that your pattern, your special pattern for multiplying, this is where it comes in really handy because you can much easier multiply this. But if all you can do is distribute, that's what we're going to do. We're going to work it through. So our first term is the square root of x plus 2 times the square root of x plus 2. But here's the thing. That is the same thing. So what that means is we have the square root of x plus 2 times itself, which is a way of saying just square it. Okay, so that's useful because that means that first term is just x plus 2 because that undoes the radical. Okay, so that wasn't too bad. Then we're going to have the square root of x plus 2 times 1. So plus the square root of x plus 2. Okay, can't do anything to that, so we're going to leave it. Then we're going to have 1 times the x squared, 1 times the square root of x plus 2, which again, so again we have a 1 here, we have a 1 here, square root of x plus 2. And then 1 times 1, that's something we like, equals 3 minus x. Shoo, okay, so we've already simplified that first term. It's x plus 2. These guys right here are like terms. They have the same exact radical, which means we're going to do 1 plus 1, which is 2 square root of x plus 2. And then we just have good old 1 hanging around. So if you'll notice up here, bum, 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 note, you may need to do this step. So raise each side of the equation to the same power. You might have to do this step twice in order to eliminate both radicals. Okay, sometimes more than twice, but usually sometimes even just twice. So we still have a radical, this guy right here, which means we have to isolate that radical now. We have to do it again. So the first thing I'm going to do is I'm going to collect all these terms. So all these guys need to go to the other side. So right now I have 2 square root of x plus 2. I got that x hanging around, and I got that 3. So we're going to take the x to the other side. We're going to subtract it. So he moved. Okay, so this guy, he's out of there. And then we're going to, 2 and 1 is 3. So we're going to subtract 3 from this side as well. Okay, so all I did was move the x, the 2, and the 1 over. So this is going to equal, well, 3 minus 3 is 0, and negative x minus x is negative 2x. Alright, so now we're going to take this. We still have to isolate the radical, so we're going to divide by 2. So that's 1, so the square root of x plus 2 equals negative x. Alright, to undo a square root, we're going to square both sides. So the right side, that's eliminated. So we have x plus 2 equals negative x times negative x is x squared. This is a quadratic, so we're going to let it equal to 0. And I like the fact that x squared is positive 1, so I'm going to subtract the x and the 2 over so that I don't have to factor out a negative 1. Because again, most likely this is going to factor, and it does. So x and x minus 2 plus 1, which means either x is positive 2, or x is negative 1, or it's both of those, or it's neither of those. We have to check. Alright, so we're again got to plug this back into the original. So the square root of 2 plus 2 plus 1, is that equivalent to 3 minus 2? So the square root of 4 plus 1, is it the same thing as the square root of 1? So is 2 plus 1 equal to 1? Nope. So that means 2 is a no-go. Alright, the square root of negative 1 plus 2 plus 1, is that the same thing as the square root of 3 minus negative 1? So we have the square root of 1 plus 1, and this is the square root of 4. Square root of 1 is 1. 1 plus 1. Last time I checked, 1 plus 1 equaled 2. So you can't just assume that you throw out the negative. So in this case, the negative 1 was the correct answer. The positive answer didn't work. So 2 is extraneous, negative 1 is our good solution. Okay, this is as complicated as it's going to get. So if you can follow this one and do this one, you're in good standing. Okay, if you got a little lost, that's okay. We'll talk about it more after the homework. Just try them. Okay, make sure you have all your steps. The big thing here is being neat and not trying to do everything in your head. Write it down. Okay. All right, last type to solve is solving equations with a rational exponent. Okay, so what I mean by that is something like 4x to the 2/3 power equals 36. So if you recall, that's still a radical equation because it's a cube root. Now, we want to isolate the x. So you can, if you wanted to, you could change this into a radical equation. But it's much easier to just eliminate the power. Okay, so what I mean by that is the first thing again we're going to do is we're going to divide by 4 because we need to isolate the x. So that's going to give us x to the 2/3 equals 9. Now, to undo a 2/3 power, we want it to be a power of 1. Our goal is to say x equals a number. So 2/3, to make 2/3 equal to 1, we need to multiply it by something, and that's a property. That something is 3/2. It's the reciprocal. So we're going to take both sides and multiply it to the 3/2 power. Oops. Sorry guys, I don't like to my work. So we're going to take and multiply both sides to 3/2. By doing this, it makes the left side have a power of 1. But here's where you've got to be really careful. If you recall from our power properties, if you take a even root of something, you have to put the absolute value. So if you look right here, when we raise this to the 3/2 power, that meant we're going to multiply it, we're going to cube it. That's what the 3 did. But the 2 on the bottom, sorry guys. The 2 on the bottom is a square root. So this guy right here is a square root, which means we are taking an even root. We're doing two things at once in this problem. We're getting rid of a power and we're getting rid of a radical. Two important things. So because we're taking the square root, we have to put the absolute value of x here. Okay. Now on the other side, we're going to have the square root of 9 cubed. So notice we're taking the square root of both sides. Again, this is the reason why we need the absolute value. So we have the absolute value of x equals 3 cubed. So the absolute value of x equals 27, which means x equals plus or minus 27. And again, we can check this by plugging it in. Okay, so 2/3, 27 to the 2/3 power times 4. Okay, so if we check that out, four times 27 to the 2/3 power. Okay, so if you will plug that into your calculator and see if it equals 36. Okay, I'm sure it does. Okay, because it's the cubed root of 27 is 3, 3 squared is 9, 9 times 4 is 36. And the same thing when you plug in negative 27. Okay, we have the cubed root of negative 27, which is negative 3, and negative 3 squared is positive 9. So you end up with 36 equals 36. So both the solutions here are answers, plus and minus 27. All right, last one, number 6. X plus 2 to the 3/4 power minus 1 equals 7. So the first thing we're going to do is we're going to isolate that power right there. So we're going to, the power. So we're going to add 1 to both sides. So x plus 2 to the 3/4 equals 8. Remember, to undo this 3/4 power, we're going to multiply both sides by the reciprocal of 3/4. So that means we're going to take both sides and multiply it by 4/3. So on the left side, we're going to just have x plus 2. But we have to decide, do we need the absolute value bars? Well, we're taking a cubed root. So since we are taking a cubed root, we do not need absolute value bars. And then on the other side, we have the cubed root of 8 to the 4th. So x plus 2 equals, cubed root of 8 is 2. 2 to the 4th is 16. And then you subtract 2. So x equals 14. And then, of course, we would want to check this back in the original. So is 14 plus 2 to the 3/4 power minus 1 equal to 7? Well, 16 to the 3/4. Again, this would be much quicker on a calculator, but I don't have one, so by hand is what we will use. So 4th root of 16 is 2. 2 cubed is 8. 8 minus 1 is 7. So our solution does work. Always checking these radical equations. Okay, you are done with the video notes, so if you will please make sure those end up in your notebook under notes, and then make sure you get your homework, which is going to be the practice for this. Okay?